Now let's talk about little bit, very little, uh, on how can we implement a pipeline. So in the easiest sense, let's try to review this R-type instruction data path, okay, and we partition this data path according to the resource it uses. Okay, so instruction fetch uses your instruction memory. That is the most prominent resource, and of course it has a PC inside it. That's fine, but most prominent resource is your instruction memory. And instruction decode and register fetch in the data path, most prominent resource it accesses is a register file, and exe phase it accesses ALU, and write back phase it uses the register file, right? So instruction fetch it uses instruction memory, register fetch it uses register file, exe phase it uses ALU, write back phase it uses register file. Once again, that's a resource, but it's the writing side of the register file. What we do with this partition at the partition boundaries, we make bunch of flip-flops, okay, and the data flows through this bunch of flip-flop from one stage to another. So in the boundary of instruction fetch and instruction decode, we make a bunch of registers there, bunch of flip-flops. A register to be precise, basically flip-flop cannot be used directly. We need to have a control over selectively load some data, not load some data, etc., etc. But point is that each clock cycle, information from one instruction flows to the next stage, where the previous stage start engaging in next instruction. So instruction, let's say instruction 1, instruction fetch is done. That instruction information, the machine code and etc., will be transferred in the register fetch stage and instruction decode stage through the register, so that the input side of the register is now free to make another fetch, next instruction fetch. Now, while the next instruction 2 is being fetched, your register fetch is done for instruction 2, and at the end of that cycle 2, all the data coming from are produced from this state are goes into the execution resources via another bunch of register which is placed in the junction of your instruction decode and exe phase. Okay, so your instruction 2's data goes over for the cycle 3, where your instruction 2 comes into the register fetch stage at that cycle, and instruction 3 being fetched from the instruction memory. So that's how data flow from instruction to instruction in a pipeline fashion through these registers. And control signals is also similar. So after instruction fetch is done, only then your controller can kind of determine what kind of control signals to be sent out for different resources. I hope by doing project 2 you have these ideas, right? So control signals are actually values are very much depending on the what instruction controller is executing at this moment, right? So after the instruction fetch, okay, your instruction is decoded and controller decide onto the further control signal to be given to those different resources like ALU, register file, memories, etc. And those signals, we can categorize them into groups like signal for the exe phase, signal for the memory phase, signal for the write back phase, and that signal also flows through this register sitting down at the boundary of instruction decode and execute phase, execute and memory and write back phase, and signal gets consumed. So exe group of signal get consumed during the exe phase, memory group of signal is consumed during the memory phase, and write back related signal are consumed during the write back phase. So that's how, in a very nutshell, very summarized way, a pipeline is implemented. Details are, of course, it's out of our scope. We should not go there in the details, that how the forwarding works, how you can imagine some things there, but let's not go into the detail. We also need to take care of how the stall happens. Stall is relatively simpler. What happens, you just stop the clock so that data transfer doesn't occur in that clock cycle between that related stage of pipelines, and then how that purge instruction purge from the pipeline occurs, that's another challenge. So those are the complex things, probably is part of, or should be at least, is part of 247. Let's hope it's there. And if you're interested, you can always pick up that course 247 as your elective and study further on this area. So that's all for our lecture 15 today. If you have any question, let me know over email or ask me in the class.